Be present, revisit anything. An approach towards visual place recognition using image segment retrieval. Consider a robot visiting a new place and storing reference map of images as it traverses its path. Now imagine it is revisiting the same place and recording a new query image under different circumstances. The objective of visual place recognition or VPR is to find the best matching image for a given query from the pre-built reference database. Segment Anything model or SAM proposed by Meta AI is the first foundation model for segmentation. It has zero-shot generalization capabilities to unfamiliar objects and images. We propose using the Segment Anything model for the task of revisiting places, which we call Revisit Anything. Standard VPR approaches encode and match the whole image. This can lead to incorrect matching because the similarity of overlapping areas can be dominated by the dissimilarity of non-overlapping areas. In these images, even if most of the image appears the same, they are actually from different places. Therefore, the solution here is to match the discriminative segments which can effectively differentiate the scene. Additionally, current VPR methods only excel in urban driving scenarios because of dataset specific training and do not generalize well to diverse conditions. The approach named Anilog proposes using foundation models as a significant step towards universal place recognition. However, Anilog faces the same issue of whole image matching. In these examples, Anilog is unable to correctly retrieve the right image. We built on top of Anilog's approach of using foundation models for VPR and propose Revisit Anything. Our proposed approach first constructs overlapping subgraphs of segments, then extracts descriptors for the supersegments, and finally converts segment level retrieval into image level. To construct supersegments, we first create a graph of segments using Delaunay triangulation. This gives us an adjacency matrix defining segment neighborhoods. We then expand individual segments by multiplying this adjacency matrix with the original segmentation masks. To extract descriptors for supersegments, we use dense pixel-level descriptors from powerful encoders like Dino V2 combined with hard VLAD aggregation at segment level. Our method factorizes the aggregation process, representing it as a matrix multiplication of the adjacency matrix, segmentation masks, and feature residuals. Once we perform retrieval at the segment level, we use a similarity weighted frequency measure to go from segment level to image level matches. A look at qualitative results. In the first two columns, we can see how our method is able to identify the right segments and retrieve the correct image. even in indoor and aerial datasets. Our method sets the new SOTA in VPR across diverse environments as shown in these benchmark comparisons. Our method comes in two variants. The FineT version, which uses a VPR fine-tuned DynoV2 backbone, generally excels in outdoor street view datasets as seen in Table 1. Meanwhile, SegVLAD PT using a pre-trained DynoV2 backbone shows remarkable performance on out-of-distribution datasets in Table 2. The difference being highly noticeable in the cases of indoor and aerial datasets. Thank you for your time. Check out code and more at this website.